Bismillah. Okay, good morning. So today we're looking at exercise 4 on page 94. Exercise 4.4 on page 94. So the first question says, or the introduction says, in the diagram the point A, which is 1 and 0, B, which is 4 and 0, and C, which is 3 and 4 are given. A1, B1 are inclination angles of line AC and BC respectively. Okay, so that's the angles they're referring to. The first question says calculate the size of the following correct to one decimal place. Okay, so to calculate the inclination or the incline of line AC, what I need is the gradient of AC. So your gradient formula is y2 minus y1 over x2 minus x1. So it's 4 minus 0 over 3 minus 1, which is 4 over 2, which is 2. Okay? So now to calculate the size of angle A1, tan of A1 is equal to that gradient of that line, which is 2. So arctan of 2 is 60 something. 63, 4. So I would assume they would want you to work to one decimal place. Okay. So your angle A1 is going to be 63, 4 degrees. So let's look at B. In B, they want you to work out angle B1. Okay. So you say tan of angle B1 is equal to the gradient of BC. Okay. So the gradient of BC is going to be changed in y. So it's 4 minus 0 over 3 minus 4, which is going to be 4 over negative 1, which is negative 4. So you say tan of angle B1 is equal to negative 4. So we got arctan of negative 4 gives us negative 75,96 plus 180. 79,46 plus 180, gives you an angle of 104,04. 104,04. Okay, so that's the angle B1, 104,04 degrees. Then the last question says you must calculate angle C. So there's a Euclidean geometry rule that says the exterior angle is equal to the sum of the two interior opposite. Okay, or geometry rule. Exterior angle is equal to the sum of two interior opposites. So that means to say that angle C is equal to 104,04 minus angle A1, which is 63,4 degrees. Okay? So you put the in the calculator minus 63,4 degrees. Gives us an angle of 40,64. Okay. If I had made any errors in the video, please contact me on that number. Otherwise, if there's an easier way to do it, please let me know. Otherwise, videos are free. Okay. Okay, now we're looking at number 3. Number 3, we are told that A, which is negative 2 and negative 2, B is 1 and 2, C is 2 and negative 1, are 3 points in the Cartesian plane. Alpha and theta are inclination angles of the lines AB and BC respectively. The first question says calculate the magnitude. Magnitude is basically the size of the following correct to one decimal place. So they want you to work out theta in the first case. So tan of theta is equal to the gradient of BC. Okay? So the gradient of BC is going to be negative 1 minus 2 over 2 minus 1. It's going to be a negative. So tan of theta is going to be negative 3 over 1, which is negative 3. So what I do is I put it in the calculator. Arctan of negative 3 gives you negative 71,57 plus 180. It's going to give you 108. So your theta angle is 108, 4 degrees. As they So it's set to 1 decimal place. Okay. Let's look at the second part of the question, or the B part. The B part of the question wants you to calculate alpha, which is this angle there. So tan of alpha is equal to the gradient of AB. The gradient of AB I can calculate. It's going to be 2 minus minus 2 over 1 minus minus 2. Which gives me 5 over 3. Okay? So now we got arctan of 5 over 3. Arctan of 5 over 3 gives me 59,04. So 59,0 degrees. That's Celsius, no? In C, the question is to calculate the size of angle B. Again, your exterior angle is equal to the sum of two interior opposite. So you're going to get 59 plus angle B is equal to theta, which is 108,4. This is 108,4. Exterior angle is equal to the sum of two interior opposite. So angle B is equal to 108 minus 59. 108.4 minus the answer we calculated gives you 49,4 degrees. Okay. Alright, so with number 5, the equation of the straight line through L and P is y is equal to x plus 3. Then we are told that MP is a straight line. This is now this line with the negative gradient of negative 2x minus 1, the equation of that line. LP and MP intersect at point P. Then we are told that L1 and L and M1 are the inclinations of those lines respectively. First question, you must calculate L1. So to calculate L1, so tan of angle L1 is equal to the gradient of LP. Okay? So angle L1 is equal to, tan L1 is equal to the gradient of this line, which is drawn from here, is 1. Remember, once the equation is in the form of y is equal to mx plus c, m is the gradient. So the gradient of this line here is 1. So it's an arctan of 1 is going to give you an angle of 45 degrees. Okay. Let's look at B. The B part of the question says, let's calculate M1 to 1 decimal place. No? So is that angle there? So in other words, tan of angle M1 is equal to the gradient of PM, which is this line. But we know what this gradient is, negative 2. So tan of M1 is equal to negative 2. Arctan thereof is negative 63, something. Arctan of negative 2, negative 63,43. Plus 180 degrees. Okay? Because the angle is obtuse, so add 180. Gives me an answer of 116.6. Okay? So just fill that in here. 116.6. As you can see, it's the obtuse angle. Then they want you to work out angle P1. But now we know that exterior angle is equal to the sum of two interior opposite. Okay? So I then say 116.6 is equal to 45 degrees plus angle P1. Exterior angle of triangle. So it's 116 minus 45 gives you 71,5. So it's 71,6 degrees. Okay. So that is 71.6. Then they want P2. So that will be simply angles on a straight line. So it's 180 minus 71,6. So P2 is equal to 180 minus 71,6 degrees. The angles on a straight line. So they give you 108.4. Okay. That is fairly simple. Okay, so I've realized I made a mistake here. This angle is not right. Why? Because you got 2 minus minus 2 should have given you 4 here. Okay? Which then gives me an alpha angle of, so So it's arctan of 4 over 3. It's going to give you 53,13 degrees. So that must be 53,13. So you say 108.4 minus that angle gives you 55, 55,3 degrees. Okay, so sorry about that.